So last day we have ended with the definition of this DFA, and we have seen one example that how we can design a DFA, and we will actually continue with some more examples to be habituated with designing DFA in various perspectives. So let's start. So suppose today, we will actually do couple of examples. So first one, let's take a language something like L equal to a string belongs to 0 1 star. That means it can be any combination of 0 and 1, but there is a criteria that x, I'm sorry, it should be w has a substring zero one zero. What does it mean? It means that the string can be any combination of 1 and 0, but somewhere in the string, that may be the first three character, that may be the last three character, that may be the some three characters in between them, should have at least one occurrence of this 0 1 0 as a substring. That means for example, let's take an example, say 1 0 1 0 1 1. You see we have a substring 0 1 0 over here. For example, 0 1 0 0 0 1 0, possible. And you see in this particular substring, in this particular string, we have two part, both the first three character and last three character is 0 1 0. But we are interested to keep at least one substring. If I have more than one substring, that is welcome, but that I should have at least once. So that means one. That means if you say that if I start with 0, then 1, then again I write 1. It's not a substring. 0 1 0 is not present. Say for example again if I start 0, then again 0, then 1. Still there is no presence of 0 1 0 over here, right? So that means this particular substring will not be accepted. This particular string will not be accepted by the DFA or the grammar or the machine, whatever you can say. And these two particular strings should be accepted by the machine. Now, question is that how we can design the corresponding DFA that can accept any string having a substring 0 1 0, something like, as an example, this one or this one, or it will reject the string something like this. As we all know that we have seen in case of designing a DFA, it's something like DFA scans the symbols one by one, and depends on the symbol scanned and current state where the DFA present, it changes the state. And in this way we have to design the DFA in such a way that if the string is within the language, then after visiting the last character of the string, the DFA should be in the final state. Otherwise, the DFA will not accept the particular string. So that means in this type of problem, when it is forcefully given that it has to have a string, substring something like this, that means one thing is clear, that somehow it has to, if I consider there is a state, some state, okay, there is some state, I'm not numbering it right now, I must have a path where I have to follow 0, then 1, then 0, right? So that means if I am, say for example, in this state, say this is Q0 state, okay, and I somewhere, I don't know how I came in this Q0 state. I will think about it later. But after visiting say some couple of characters in the string, if you are standing on this q0 state, to be accepted that particular string you have to go through 0, 1 and 0. Now how you can ensure it? You can ensure by keeping a deterministic path that will actually follow this 0, then 1, then for 0. That state transition will be for this. So that means from q0 to q1, say for example the next state say I am considering as q1, I must have a deterministic path from q0 to q1 because of the first 0. Similarly, I have to have a deterministic path for 1. So I must have another path. Say this is q2, 1. And then I must have a deterministic path 0, q3. Yes. Now see, you know, I don't know from how I came in Q0. I mean, if I consider that this is the starting state, then it is okay. I will start from here. You know, the initial state. I mean, when I am uh, about to start checking the characters, I'm standing on this Q0 state. So then I can start from here, and to reach to the final state, you have to go through the 0, 1 and 0. And somehow, if you have this, then it's over. You don't need to think about after 0, 1, 0, what combination of 0 and 1 is present. There is no need. For example, take an example something like 0, 1, 0. So suppose these three characters are the first three character of a string, and after these three character, whatever the combination of 0 and 1 present doesn't matter. It should be accepted because this 0, 1, 0 is present. I have already found 0, 1, 0. So that means by this deterministic path 0, 1 and 0, when you will reach Q3, there is no way to reject this string, whatever other 0 and 1 present from this Q3 onwards. That means I can say that okay, I can keep this particular state as a final state. That I have already seen 0, 1 and 0. But after this, as I told you that you must have any combination, and one most important thing is that since it is deterministic finite automata, that means from each and every state you must have the option for all the alphabets. I mean all the symbols of the alphabets. Not only that, but also you must have a dedicated path. What I mean that from Q3 where I will go. I mean my string is large enough. So 0, 1, 0 is not the string only. It's a part of the string, and after this maybe I can have 1, 0, 1, 1, 0, 1, or maybe 1, 1, 1, 1, or maybe 0, 0, 0, 0, or maybe 0, 0, 1, 0, 0, 0, something like this. Any combination is possible. But whatever combination doesn't matter, it should be accepted. So as soon as I got that 0, 1, 0 is present, I will remain stick within the final state. So that means as soon as you will reach the final state, you don't need to think about what the character now the read head is going to read. You should stick within the Q3. That means I must have a self loop for 0. If I get a 0, then I will remain in the final state because you have visited 0, 1, 0. Even if you find a 1, then also you should remain in the Q3 state. So 0 and 1, something like this. But still the job doesn't end here because if I consider this Q2 state, I have a dedicated path for 0 from Q2 to Q3. But what about 1? I mean, I started journey from Q0. Suppose that this is my initial state. I can consider it. So if it is my initial state, obviously I must have a arrow towards this Q0, as we know. Now, as we have seen that it may starts from 0, right? It may starts from 0. And you see, uh, I don't know, before I get the first 0 of this substring 010, how many 1 will be encountered. I don't know. I mean, for example, a string can be something like 111010, something like this. So how many times 1 is occurring is not important for me. It is important when I'm getting the first 0. And that's why I have kept a dedicated path. As soon as I'm getting the first 0, I'm going to some state and then I will do something that I'm telling later. But what about this all the 1? Till I don't get any 0, I will remain in the state Q0. So I must have a self loop Q0 to Q0 as for 1. So for all the 1, I will remain in this state, and as soon as I will get this 0, you see now I can have two possibility. That, I mean, I have got some 1s, for example 3 1 I have got, and then suppose I have got a 0. Okay, fine. So now see, I don't know what is present after 0. I don't know means actually the machine doesn't have any idea, because machine is reading the characters one at a time. So machine reads character 1 first, it remain in Q0. Then for other two 1 also, the machine state is remain in Q0 state. Fine. And when the machine will find a 0, machine may consider, I mean, there is a two possibility that obviously it can be the first 0, first character of the substring that we are searching for, right? So if we take it positively, that okay, this may be the first character of the substring that we are searching for, we must have a dedicated path to keep remember that we have seen a 0. That's why I have kept this one. Fine. But after this 0, I can have two possibility. I can have a 1 or I can have a 0. Right? Now see, an interesting point is that ultimately I require 0 1 0. So that means if I have a 0, then there is no harm to realize, to consider that maybe that this 0 was not the first character of that substring that we are searching for, but the next 0 that I have got is the first character of the searching of the substring. That means still my hope is not in end. Still I can hope that I will get a substring 010. Since I can hope this, that means for a 0, when you are staying on Q1, and if you get a 0, you should not remain, go somewhere. You should stick on this Q1 for some time till you are getting a 1, something like this. You will remain in this state, and a time may come that it will become 1, right? So when you will see this 1, then you will realize that okay, I have seen a 0 and then I have seen this 1. So still I have, that means I have proceeded towards the final state once more. So that means I can change my state from Q1 to Q2. I have a dedicated path for this. But here still again I have the same catch. I mean that the one that I have seen is the second character of the substring that I am searching for. Fine. But after this one, I have again two possibility. If I find it is 0, that means I have got it, got the substring 010. But if it is not 0, if it is 1, then the entire hope just will go to the end till I get again another 0 in the substring. What I mean that if I find 0 1 then 1, then there is no way to to hope that maybe I have a 0 1 0 still now, right? So that means as soon as I will get a 1, the previous assumption that I have seen the first two characters of the substring 0 1 0 is diminished. Is not will not exist, right? So that means what will happen? That means what to do? That means I have to, if I consider I have more characters after this string, I have to again search for the first character of the search string. That means I have to again search for a 0. Till I will not get a 0, again similar searching for other two characters will not start, right? So that means if I get a 0, instead of this, if I have a situation something like this, I have this one, and then after this one I have got a 0, I will go directly go to the Q3, and this is my final state. So after this, whatever character present or whatever 1 0 combination present doesn't matter for me. I've got this 0 1 0 as a substring. And when the read head will reach to the end of the string, we will see the machine is on the final state, so it should be accepted. But if the situation is something like this, then what will happen? That means somehow after some characters, say for example 1, then 0, then 1, suppose, I'm sorry, why 0? Say 1. Suppose that I have some 1 over here, meaning a number of 1. Then somehow, and after this maybe I have a 0. So this 0 can be the first character of the substring that I am searching for. Now, when I am standing on this 1, that is 0 1 I have just seen, this 0 and 1, and then I have got this third one, the second one, we have seen that we will understand that okay, this cannot be the substring, so I have to look for a 0. Now for this one I will where I will go, this is the question. First of all, where I am standing, I am standing on this Q2, right? When I will see 0, I will come from Q0 to Q1, and for other zeros also I will remain in Q1, but when I will get a 1, I will go to Q2, fine. And here if I find 0, then it's okay. If I find 1, then I have to start searching the substring 0 1 0 from the beginning again, right? That means when I will get a 1, there is no other way. I have to go back to the first state, and I have to start searching for another 0 that may be the first character of the substring that I am searching for. And you see, if I have any number of 1s, say till this 4 1, because of this particular one, I will go to Q0, and for other 3 1, I will remain in Q0, and then when I will get this 0, I will come to Q1, and then if I assume that I have a 0 1 0 something like this, so automatically for this particular 0, I will go from Q0 to Q1, then for this one I will go from Q1 to Q2, and for this 0 I will go from Q2 to Q3, and at the end of the string I will see that I am in the final state. The machine will see that machine is the final state, so that means it should be accepted. Now any other situation if arise, for example, consider a situation something like a number of 1 is present, okay, say 3 1 is present, and then a 0 came, fine. So this 0 could be the first character of the substring, I don't know, the machine doesn't have any idea about the other characters. So second character, the next character that machine has read, say suppose 1, okay, still hope remain that maybe I'm going to get the substring 0 1 0, but suppose the machine found the next character as 1, So what will happen? Due to this path, this machine will go from Q2 to Q0 state, and if I assume that I have a number of 1 and then a 0, and here your string stop, what will happen? For this one, I mean, before, let's elaborately draw it. Take a situation something like this. 1, 1, 1, then 0, then again 1, then 1, and then 0, right? So now assume that we are here. Right now the read head is here, and what is the state? Obviously Q0, because this is the initial state. Now on reading this 1 and Q0, where Q0 will go? Q0 will go on reading 1, Q0 will remain in Q0 because of this DFA. So that means when the character, the reader is about to read the second character, after reading this 1, it will remain in Q0. Fine. After reading the second one, still the machine will be in Q0. After reading the third one, still the machine in state Q0. Fine. Now it has got a 0. So when the machine will get 0 and machine is in Q0 state, so Q0 on 0 it will go to Q1. So that means the state will now change and will go to Q1. So we are going towards the final state, maybe. So because this may be the first character of the substring that we are searching for. Now again I have got a 1. So because of this one, I've got this 0 and 1, two part. So that means from where I'm now Q1. So Q1 on 1, I will go to Q2. I'll go to Q2. Fine. And now somehow we have to read a 0. If I get a 0, then right now if I get a 0, then it is okay. If I don't get 0, then entire searching is lost and I have to search a 0 again, right? So, and unfortunately what the machine has seen a 1. As soon as machine has seen a 1, there is no way to just abort the searching for 010 right now. It has to search again a new 0 that may be the first character of the substring. So that's why because of this one on Q2 on this one, it will go back to Q0. You see, I'll go back to Q0 and it will start checking from the beginning again, as if that this 6 characters is not present in the string. The situation is something like this, like Q0 was here and Q0 came here. So keeping, present this 1, 2, 3, 4, 5, 6 characters doesn't have any significance, at least with respect to accepting the string, right? Anyway, so now I'm in Q0 again and I'm getting a 1, so it is not a part of the substring, so I will remain in Q0, and again I'll get a 1, I will remain in Q0, and then I got a 0, which may be the again first character of the substring that we are looking for. So because of this, again the machine will proceed towards the final state, that is Q0 to Q1. But you see, unfortunately, after reading the last character, after reading the character 0, the machine will realize that this is the last character of the string and nothing is present in the string. So the machine will stop, and when the machine will stop, machine will check what is the current state where the machine belongs. The current state of the machine is Q1, which is, I'm sorry, which is basically not in final state. That means this particular string will not get accepted. So this is the way actually our DFA actually works, and this is the way you can think to design a DFA for some language.